Reading time, colored pens. Number 1 is a review of the last lesson. Number 2 is a review of a concept from long ago. So let's start with number 1. Very challenging question. But all I asked you to do was to write the system. So I'm going to ask you to give me one equation from the system. So I need some volunteers to give it a shot. And again, keep in mind this was very challenging. We'll start with Sharik, and then Kamoy, then Ania. Sharik, give me one equation.
X plus y equals 45,000.
Okay, Kamoy, did you have that exact equation? Okay, what was one that you wrote? What was that last one? Okay, so a little bit different. Okay, Ania? Okay, good. So we got 3 different equations floating around. So let's reveal the first one. The simplest one was that. X plus y equals 45,000. Now this is, with me, the third time you're seeing one that's like this. And you're going to see it more and more and more. Where you have a total, and it's being divided into 2 different quantities. One quantity is x and one is y, and so x plus y must equal 45,000. We saw this in the actual lesson last time as well. The second equation was really hard, and someone said it, but they made a mistake because it has to do with understanding what percents are. So, here was what Ania said, except she misunderstood how to write a percent. So the second equation is 0.055x plus 0.065y equals 2,725. So let me give you the explanation I gave to a couple of your classmates who asked, how do you know when to write 5.5 and how do you know when to write it as a decimal? We use this symbol and this form when we're talking about percents, or when you're writing an article that people are going to read, or when you're doing something online and you're trying to type something up and you're talking about percents. It's how we communicate about percents. But if you're going to actually calculate with a percent, then you must convert it to its decimal form. That's when we convert it to this. So here we're going to do some math with it, so we convert it to its decimal form. If we're just going to talk about it, then you leave it at 5.5%. For example, if I wanted to say to you, hey, what's LeBron James's free throw percent? You might just say, oh, he's an 88% free throw shooter. But if I then wanted to predict how many free throws he would make in the next game, I wouldn't use 88, I would use 0.88. So if we're talking about it, we say 88%, but if I'm going to use it, I then say 0.88. Give me a thumbs up if you understand. Thumbs up if we feel comfortable with it. Good. Very good. So, any comments or questions about number 1? Go ahead.
I got the first part of the equations right, but how do you know how the 45,000 and 2,725?
Oh, yeah, and that was really hard. So some people flip-flop these numbers, and it was very hard to tell. Okay, so this one in particular, because you've never invested anything before, you don't even know how the world of investing works. So it has to do with the numbers that are totals and what pertains to them. So this number here is a total. It's the total amount of interest. So once you see that this word is connected to this word, then you can see that the 5.5 and 6.5 also have the word interest connected to them as well. So then you can start seeing that, okay, so now I'm going to be using this and this with this number. Now, if you were a 22-year-old adult that had done investing, you might view it a little bit differently and you might instinctively understand. But being that you don't have any experience with that, you would have to really just look for words and try to interpret the words. Okay? But you're right, it was hard. It was hard. I did not get this question right the first time I did it. Not at all. So don't feel frustrated. It's a hard question. So now to the easy question of the warm-up. Number 2, what'd you get? So Hezekiah, Stephanie, and then Maria. What'd you get? Okay? I'm sorry? Okay, I just didn't hear you. Maria? Y was 2. So we have some disagreement. Anyone else want to chime in with a different answer or one of those? Alicia? 2. So there seems to be more support for 2. Kayla? 2. So the correct answer is 2. If you did not get 2, now you need to go back, look through your steps, and try to figure out where you made a mistake. If you can't find your mistake, then you're going to ask a classmate to see if they can find your mistake for you. There's no shame or anything wrong with making a mistake. But you're going to be doing questions like this a lot today. So if you're making a mistake now, I'd like you to be able to figure it out. So any comments or questions on number 2 or back to number 1, anything at all? Good. So let's put this to the side. Today I'm going to introduce the second method for finding a solution to a linear system. Last time you learned how to graph a system and then find the point of intersection. That point of intersection is the solution. So that's what we are trying to find. We're trying to find a point. Now, number 16 on the homework was an example of the inability of that method to be 100% accurate all the time or to be really very effective. Graphing is subject to human error because you're physically trying to draw something, and it's difficult to draw something perfectly without using a computer. So there's some issues with that method. But the method is really important for you to understand what it is we're really looking for. Now you should understand. We're looking for a point where 2 lines cross. You should have that in your brain. Now, I'm going to teach you 2 methods, one today and one next time, that can find that point without drawing the graph. That's a huge step up, because now we don't have the hassle of drawing these elaborate graphs with 2 lines and then trying to find the point, and then if the point's not on the lattice, then we have to guess and keep checking until we get the right one, like in number 16 from the homework. So today, the idea is to figure out a way to find the solution without having to go through with all that. And the method we're going to use today is called substitution. So, step 1. We're going to solve one of the equations for one of its variables. You learned how to do this way back at the end of chapter 3 when we learned function form. If possible, we want to solve the equation that has a variable where the coefficient is 1 or -1, just because that's easy. So we're going to call this the first equation, and we're going to call this the second equation. First and second. Which one has a variable with a coefficient of 1 or -1? First equation and the second one. Brandon? Second one. Alicia, what were you going to say? The second one. Which letter has the coefficient of 1? Y. Very good. So, I'm going to use the magic of the computer to magically convert this so that it is now isolated. This is what you learned way back at the end of chapter 3. So you already know how to do that. So now, y is by itself and it's in function form. But the key is to have the y by itself. So the name of the method is called substitution, and so that's the first step. And here's what we are going to be looking at. Step 2. Substitute the expression from step 1 into the other equation. So let me show you what I mean. I have here exactly what I have up here. Now watch what we're going to do. Y is by itself, which means y is equal to this expression right here. I'm going to take this expression and put it in place of the y over here. Watch how we do this. We're going to take the y out and replace it with parentheses. And now I'm going to take this expression and copy it right into there. How many variables are now in the top equation? Ania? How many different variables are now in the top equation? There's only one variable. And so when there's one variable, now we can solve it. So now we solve for x. That's what it says, solve for the other variable. We solve for x. Step 3, now we substitute the value that we found here back into the other equation to find the y value. Once we have the x and y values, we just found the point of intersection without having to draw the graph. So, it does take some practice. It's going to take some time for your brain to kind of get it. But within the next 30 minutes or so, it should start making pretty good sense. So, first we're going to work on how to decide which equation to isolate. If you're missing any of this, don't worry about it. Skip a couple lines. I have it printed right here. You can borrow it in a few minutes. So, example 1. We want to become very proficient. In fact, we want it to be almost instant to be able to tell which equation we should isolate. Now, it actually doesn't matter. You can isolate either one you want. But it's about which one is the best choice, which one is the most efficient. So part A, the system is 6x plus y equals negative 5, 2x minus 3y equals 10. Which equation is going to be easier to isolate? Number 1 or number 2? Caleb? The first one. Which variable has the coefficient of 1? The y. So you should be looking at this equation, and specifically you look right there and you say, oh, well, that makes it easy. So now we're going to isolate that variable. So this is step 1 that we're learning how to do. So now we're going to come, excuse me. So now we're going to come here. And how do I isolate the y? What's the first thing I should do? You should be an expert at this. Sebastian? Subtract 6x from both sides. And in fact, that's it. Subtract 6x from both sides, we get y equals negative 6x minus 5, and we have successfully isolated the variable. That was one step. Now, if I really wanted to, I could isolate the y here, or I could isolate the x here if I want to. But it's going to take more than one step. This only took one step. Let's look at part B. Which equation should we isolate? First equation or the second equation? Which one, Anne? The second? Tristan, you agree with that? Okay, why? Okay, well that's fair. Could someone explain why the second equation is better? Hezekiah? Yeah, what's that number called? There's a name for it. Sharik?
The coefficient.
The coefficient is 1. So, Tristan, now that's something you need to put in your brain to be able to communicate next time. This coefficient is 1. Okay? So now we need to isolate the c, so now we're going to actually do it right here. So what's the first step to isolate? Anissa? Subtract 3d from both sides. We get c equals negative 3d. And you could say plus 0, but that's meaningless, so that's it. Part C. Which one should we isolate? The first equation or the second? First one or the second? What do you think, Ania? Oh, I love the way you said that. First one's already isolated. Our work's already done for us. So we just explored step 1. Does anyone have any questions? Good. It can get confusing from here, so follow along. You work hard. You raise your hand with questions. You take some deep breaths. I promise you that it will start to make a lot of sense as you go along. So now we're going to use substitution to solve the linear system. You don't have to write equation 1, equation 2. I just put that there so we're all looking at the same thing and we're naming them the same way. So step 1, as we just learned, says to isolate one of the equations. Which one should we isolate? Tristan? Okay, why?
Because the x isn't.
That's okay.
The x's coefficient.
Very good. That was very well said. Excellent job. X's coefficient is 1. So that's what we're going to isolate. So now we need to isolate the x. What's the first thing we should do? Kimoy? Good. Subtract 3y from both sides. And so we end up with x equals negative 3y minus 1. So now what we just did was we have now said that x is equal to this expression. So anywhere we see an x, we can put that expression in its place. But you have to be careful because now we need to put it into the equation we haven't used yet. If you put this back into this equation, you end up with circular logic and it doesn't work. You get very confused. Don't worry, it's going to happen, but we try to avoid it. So the equation we haven't used yet is equation 1. We're going to take this x out and replace it with a set of parentheses, and this is going to go in there. So here's what it's going to look like. 2 times, and that's where the x was, minus 5y equals negative 13. Yes, Brent?
So the variable that's isolated, that's the variable you substitute in the equation.
So here was an x, and x is now equal to this expression, so now I can put this right here. Negative 3y, let me change. Negative 3y minus 1. Now, I'm just going to pause here to remind us of what it is we're looking for. We are looking for this, an ordered pair. That's what we're looking for. That's what will solve the system, an ordered pair. So that's our goal. So now we're here. So let's go ahead and solve this. What's the first thing I should do? Should seem pretty easy to you at this point. Sebastian? Distribute. So we distribute here and here. And we get negative 6y minus 2 minus 5y equals negative 13. Sheree?
Simplify, add like terms.
Good. And so what do we get?
Negative 11y minus 2 equals negative 13.
Very good. How many steps do we have left to solve this, Kezekiah? 1? What's the one step?
Oh, 2 steps.
2? Okay. Well,
Add 2 to both.
very good. Add 2 to both sides. Negative 11y equals negative 11. So what is y equal to? What's y equal to?
1.
It's equal to 1. So y equals 1, which means that the y coordinate is equal to 1. So we have half of our answer. Now, find the other half of the answer any way you think you can. The good news is once you have half, the other half is super easy. You can now take this number and plug it in anywhere you want. You could plug it in here. You could plug it in here. The easiest thing to do is plug it in right there, because this is already set up to solve super easily. But you can plug the 1 in anywhere you want. You can put the 1 right here. You can put the 1 right there. But the easiest thing to do is to put it right there. So what is x equal to? Yeah, mental math, right? Zabari? Negative 4. Thank you for saying it was such drama. Negative 4. Yeah. So the ordered pair that will solve this system is negative 4, comma 1. Does anyone have any questions on the method? We put the 1 here. Negative 3 times 1 is negative 3. Minus 1 is negative 4. X is negative 4. Okay, Shelby? I'm sorry? You're going to have to use your 2014 big booming voice, because I can't hear. We're at the 2. This? Right there. All I did was I took this equation and I took out the x. That's why I put the parentheses in place of the x. Okay? Brandon and then Ann? Yeah, you could, yeah. Okay. So now I want to relate this back to what we did yesterday. What this means is that if I were to draw the graph, I don't know what it will look like. I mean, I would have to take the time to actually graph it. But I do know that the point where they cross will be negative 4, positive 1, right there. I don't know what the lines will look like. I mean, let's see, it would be, the x-intercept would be negative 6.5, so it would be somewhere over here. The y-intercept would be 2.5, something like that, so it would be over here, so there'd be a line going like this. One line would go something like this, and then the other line would go something like that. But we didn't have to do the graph, because we used this method to skip over the graph and just find that exact point. This would have been extremely helpful for a question like number 16 in the homework, where the graph was so hard because the lines did not hit the grid anywhere. And so you had to keep guessing, okay? Any questions on this? Okay, let's see it in action again, part B. So which equation should we isolate? Come on. Okay, how come? Okay, because it's positive. What's positive? Okay, very good. You said the first equation? Okay, Maria? Okay, and how does that help us? Okay, interesting thought. Brandon? Very good point. Brian?
The first one because y had the smallest coefficient.
Okay. Yeah. At this point, it's really up to you to decide. None of them are really going to be that great, so we just really have to tough it out. So I thought Brandon's idea was interesting. If we do isolate the x, then we will end up dividing by 4, and so that number will come out nice. That might be good. So let's give that a shot. So we're going to isolate that. We're going to isolate the x, which means we have to get rid of this first. We have to add that to both sides, and here's what we end up with. 4x equals 3y, and there is the benefit of what Maria said, is it ended up positive over here. That will help a little bit. Let's see. Plus 28, and now we need to divide everything by 4. And this will disappear, and we get x is equal to 3/4 y plus 7. Anyone have any questions on how we got to here? So now we have to use the equation we haven't used yet. We have to use the 2x plus 3y equals -4, but since we isolated x here, we're going to take out the x and replace it with a large parentheses. So it looks like this. And this expression is going right here. So we put in 3/4 y plus 7. And now solve it. So Sebastian had helped us before. Distribute, distribute. So I'm not getting stuck on fractions. We're not going to sit here debating this for a while. This becomes 3/2 y plus 14 plus 3y equals -4. And remember, and I got to admit, I'm forgetting I've forgotten 2 times already. But don't lose sight of what we're looking for. We are looking for an ordered pair, so our goal is to get the y value to put it here so that we can then find the x value. So, let's see, 3 halves and 3y. So that's what, 6 halves. That gives us 9 halves. Y plus 14 equals -4. Only 2 steps left. Subtract 14. How do I solve an equation that looks like that? Catalina? Very good. Multiply by the reciprocal. 2/9 times 2/9. And that actually works out very nicely. What do we get for y? Got 3 people figured it out? 5 people? 6 people? 7 people? Eric, what'd you get? -1. What'd you get, Tristan? Okay, so we have a disagreement about what it comes out to, Anissa. -1/4. We got 3 different answers going around. Are we all looking at this here? Yeah, some of you are butchering this completely. Zavari? -4. Now I got 4 different answers. And? -4. Alicia? Yeah, it's -4. You should have immediately looked here and here. -18 and a +9. -18 divided by 9 is -2. -2 times 2 is -4. So that's -4, and so we have half of our answer, -4. Now plug this in anywhere you want. You can plug it in here, plug it in here, but the easiest place to plug it in is right here. X will equal 3/4 times -4 plus 7. That's all mental math, because this and this make it very easy. Zavari, you're on a roll. Let's see if it continues. 4. Brian? Yeah, comes out to 4. This cancels this, but becomes a -1. That's a -3 plus 7. You have 4. And so the ordered pair is 4, -4. Comments, questions?
So when we say x equals 3/4 times 25 plus 7, like 3/4 like times 24, isn't that like -12/4? Oh.
But that's fine if you do that. 3 times -4 is -12, divided by 4 is -3. But I look at this and this. I look here and here. This is -4 divided by 4. That's a -1. -1 times 3 is -3. Okay? Other comments, questions? Shelby? Again, it's got to be fun. All right, I'll talk to you individually. So I'll come to you in a minute because it's checkpoint time. Let's see how you do on your own. So you got 4 minutes. basically a shortcut. This method, how much work should it do? It's a trick. What we're doing is we're changing the equation so that we now know that x is equal to this expression. So anywhere we see x, we're replacing that expression. And what that does is it changes the equation from having two variables to one variable. You can't solve an equation with just two variables. It's so we're changing it so that it's one variable. Check those out and see if it's starting to sink in. What'd you get? So the Nia, Kayla, Hezekiah, and then over here. Who's next? I lost track. Kayla? Okay. Okay, so we have a difference of opinion, Sebastian and Anissa. Okay. We have a lot of agreement that it's 2, 1. 2, 1. Okay. So, if you got it, great. If you didn't, that's okay. It's the first time you try it on your own. So you're going to have a lot more chances. So now we're going to apply the idea to a real-world scenario. So write example 3, read example 3, but you do not have to copy it down. Read it to yourself. All right. So now, and this is really the goal overall, is to just not just be given a system, but to actually construct the system and then solve the system. One thing you want to do is you want to make sure you have identified what your variables are and what they mean. We've been using x and y, so let's continue using x and y. But let's actually write down, what are they representing? So what could x represent in this scenario? Jabari? Yeah, but I'm going to be even more specific. We're going to say the number of adults. And so if x is the number of adults, what should y be? What should it be? Tristan? Yeah, the number of children. So we've identified what our variables mean. The second thing you want to try and do, especially if you're looking, if you know it's going to be a system, that will help. But you want to see if there are two totals. Are there two totals in the question? And yes or no, and then if there are, what are they? If not, what do you see? Moy, what do you see? That's right. And so we've got two totals, this and this, and so you should immediately be able to tell that it's going to look something like this. Excuse me. Something equals 1,590 and something equals 321. Now you've seen something like this a bunch of times already. So let's look at here and look at this number here, the 321. What is going to equal 321? Alyssa? Okay, and what is that being represented by? True, but I'm saying we already wrote down some representations for those things. That's right. So if we take the number of adults and the number of children and add them together, it must equal 321. So that's the simple one to set up. That's the simple one to set up. X plus y equals 321. So now, the other one is where we use the other information from the text of the question. Catalina? Yeah? Very good. So the adult admission is 6, and so to find out how much money that's worth, we take the x times the 6 to get 6x. Then we have to add on how much was spent for children, and that's 4 times the y. You can tell which equation should have the money because this is an amount of money. That's an amount of money, so we need to use the money in the equation. This is not an amount of money, so we don't need the money in this equation. Now we want to answer the question. How many adults and how many children were admitted that day? So we need to solve and find x, and we need to solve and find y. So what can we do? Four people have an idea? Go ahead, Brandon. Yeah. They both have a coefficient of 1, so it actually doesn't matter which one you do. But yeah, we can isolate the y, And so we will change this to y equals negative x plus 321. And again, what we just figured out was that y is equal to this expression. And so in the other equation, we can take out this y and replace it with this. And so here's what we end up with. 6x plus 4, and we're taking out the y. And we're going to replace it with this. Solve the equation. Distribute, distribute. 6x minus 4x plus, let's see, that's 1,284. 1,284 equals 1,590. Simplify and solve, we get 2x plus 1284 equals 1590. So what will x equal? Good, we got 5 people who figured it out, 6, 7. Go ahead, Maria. Yep. X equals 153. So what that means is on this day, 153 adults attended. So we're also asked how many children attended. How could we find that? Zabari? Yeah. We know that the total is 321, so just subtract 153, and you end up with, Caleb? 168 children. So the goal, the ultimate goal is to be able to read real-world scenarios and interpret them, write them out as systems. Okay? Good. Okay, classwork on page 75. Numbers 20, 18, 16, 13, 12, and 7. 6 questions. Got about 12 minutes. Well, this one was a little easier. Okay, colored pens up. All right. 20. A and 20B. The system was x plus y equals 12 and 225x plus 200y equals 2600. When you solve that, you get 8 mode and 4 shovels. Number 18 and 16. 13, 12. And number 7. So there were 6 questions. Give me a thumbs up if you got a 67% or higher. Good, put your thumbs down. Now I'm going to open up the floor for questions. Questions on any of these. Brandon, we will start with you. 20. Hezekiah. 16. Any others? Go ahead. 18. Sharif? Okay. Good. So let's start with number 20. So Brandon, is your question about constructing the system, or is it about solving the system, or both? Solving the system. So you had the same system. Okay. So the system was, let me just go back. It was x plus y equals 12, 225x plus 200y equals 2600. So we've got x plus y equals 12, and then 225x plus 200y equals 2600. So give me a thumbs up if you got that system written out correctly. Good, a lot of us. That's very impressive. That is a huge step for you guys. Being able to interpret this is very difficult. So you can put your thumbs down. That's a great step. So now, which equation would you use to isolate so we can use the substitution method? Anita? Yeah, it's by far the easiest. You can isolate either variable. It's totally up to you. So which variable would you isolate in? X? Okay. So we're going to turn this into x equals, and it will be negative y plus 12. And so now we have x equal to this expression, and we can take this x away and replace it with that expression. So Brandon, is that what you tried to do? Okay, but you isolated the y. Okay. Well, either way, it's going to still work out pretty similar. So we've got 225 times negative y plus 12 plus 200y equals 26. From here, it's just a matter of persevering through solving the equation. Distribute, distribute. We get negative 225y plus, let's see, what's 225 times? That's 2,250, and another 450. 2,300, 2,700. Thank you. 2,700 plus 200y. So So I know I did it slightly differently than you. Should come out pretty similar. Is there a mistake somewhere along the way that you got to try and find, or was it a matter of not understanding the process?
No, I can combine my equations, and then with 25x equals 1, and then I got to move
Okay. Something was missed somewhere. Did you not distribute to the 12? I'm going to have to come look at yours individually to see what happened. From here, this one would be negative 25y plus 2700 equals 2600. And you should be able to tell that when we subtract 2700 from both sides, we're going to end up with negative 100 here. You found your mistake? I knew something seemed off. Go ahead, Kezekai.
4 households and 8 households.
Okay. So something got confused with your money because you applied the money to the wrong job. So you did everything right, but you confused and assigned the money to the wrong job. Okay? So that's where the benefit of actually labeling and identifying your variables at the beginning. X is going to be the number of households mode. That's not how you spell mode. It would help if I could spell. And Y is the number of households shoveled. And if you write that down, that will help guide you as you construct your equations, okay? But it sounds like you understood the math behind everything, you just mismanaged the information, okay? Are there any other comments or questions on number 20? All right, now there's a question about 18. Give me a thumbs up if you got number 18 correct. A lot of people, okay? So the individual who asked about 18, I'm going to work with you individually. There's a question about number 16. Give me a thumbs up if you got number 16 correct. Okay, not as many people. Good, so let's go over number 16. Sharik, which did you isolate? And I have a bunch of people who got their colored pens ready, trying to learn and find their mistake. What did you isolate, Sharik?
For me, I had isolated the y
In which equation?
in the second equation.
Second equation. Okay. So here we're going to subtract 5x. This disappears. We've got negative 9y equals negative 5x minus 4. This is what you did?
Yes.
You divided everything by negative 9.
Yeah.
This is ugly. So we get y equals 5/9 x plus 4/9. And then you plug that into the other.
Yes.
Yeah. So I can already tell why people had trouble with number 16. Why did people have trouble with number 16? Sum it up with one word, Kayla. Fraction. So dealing with fractions was the downfall of this question. And no matter which one you isolated, you were going to end up with fractions no matter what. I can tell just by looking at the numbers, no matter what, you're going to end up with fractions. So you just got to be able to deal with them. Okay? It does come out pretty ugly this way. Go ahead, Maria. Okay. So you got this answer? Okay. Did you do it this exact same way? Okay, but you started out with this and then changed it to decimal? Okay. What is this decimal?
No, I didn't start off with that. 9 to 1.
You isolated the x. Okay. Okay, so 9/5 comes out actually a little bit nicer. Had you done it this way, these decimals do not come out exact. They come out as repeating decimals. And so that presents a different challenge. Your way worked out okay because it wasn't repeating decimals. So you got, I don't want to say lucky, it wasn't luck, but you chose wisely. Okay? Come on.
I think the other equation is
Okay, more manageable more manageable fractions and decimals. Yeah, I can see that too. With the slightly smaller numbers, it will work out a little bit more nicely. You're right. And so you also converted it to decimal, and that helped you succeed. So listen, my rule has been all year that don't convert things to decimal unless you're told to. However, there are certain situations where working this out with fractions is going to be really challenging. I mean, look what happens when we plug this back into this. We get 3x plus 2 times this ugly expression. And I can tell by the 2 and the 9 that this is going to continue to be very, very ugly. I mean, really hard to manage. This is 10, when you distribute, that's 10/9, and that's 8/9. And then you've got 10/9 x and 3x. I mean, that becomes very difficult to deal with. So in this case, I don't think choosing decimals was a bad choice. But you do have to be careful because look at what happens when you convert 5/9 into a decimal. It's a repeating decimal. And now if you round, you actually won't end up with an exact answer at the end. And so you do have to be careful. So what Kamoy and Maria did was they chose wisely which equation and which variable they isolated, which generated some simpler fractions to deal with. Okay? Comments, questions? So basically I'm saying it's okay to break Mr. Gallett's rule if you're putting some thought into it. Okay? All right. Your homework is page 451, it was 4 through 28 even and 32 to 36 even. On FL 13, you're doing days 1, 2, 3, 4, and 5. That's a total of 21 questions. And you need to read the next 2 sections because they're basically the same concept, just one's a little bit more advanced than the other. We're going to be learning it all at once. And your first quiz of the quarter will be next week. And it will be 7.1 to 7.4.